Now let's talk about the 5 shortcuts that exist for proving two triangles are congruent to each other. The first one is if all 3 sides of one triangle have the same lengths for a corresponding side on another, as pictured here in the middle at the top, then you have side-side congruence. Remember, they don't have to give you the lengths. They could have put 1 tick mark on the side lengths marked 4, 2 tick marks on the side lengths marked 7, and 3 on the side lengths marked 6, as long as each triangle had a corresponding congruent side in another triangle. You would have side-side congruence and need to know nothing about the angles. The next case in the upper right is side angle side, and it's imperative you know that that angle has a very specific quality. It's called the included angle. It has to be a congruent angle between the 2 sides marked congruent. So in the left triangle, you clearly see angle A is marked as having a specific size relationship to angle E, and angle A is between 2 sides marked with tick marks. So that is side angle side marked on the left triangle. To be congruent to the triangle on the right, it would also have to have an angle marked between 2 sides with tick marks, and it does. FE is marked, ED is marked, and angle E is between the 2. So in that shortcut, you have side angle side congruence. You need to know nothing about the other 2 angles or the other side. In the bottom left, we see a similar principle, but in this situation, you have 2 angles marked congruent to each other in each triangle, and it's the side between the marked angles. So in the lower left triangle, angle A and angle C are both marked with arcs showing they correspond to sizes of angles in the other triangle, and the side between vertex A and vertex C is side AC, and it has a tick mark. Look up at the upside down triangle above it, and you again see 2 angles marked, and between the 2 angles is a side marked with a tick mark, showing you have angle, side, angle congruence. The last step that's just angles and sides, needing to know 3 things about each triangle with respect to its markings, is called angle side. So it's still 2 angles in one triangle marked and 2 angles in another triangle marked. But this time it is a side outside of the 2 angles. It is not included. Very important that you note that you can't have half of the bottom left situation where one triangle is marked like ABC in the lower left, angle side angle, and then move over and have a different triangle marked angle side. Both triangles in the situation have to be marked the exact same way for congruence to exist. The last example of congruent triangles in terms of a shortcut is called hypotenuse leg, and only 2 things have to be marked, except you do have to know it's a right triangle. So if you look for right angles and see that, then you know, this might be a hypotenuse leg situation. Hypotenuse leg only works on right triangles. The hypotenuse is the longest side of any triangle, any right triangle. It's always across from the right angle, and then you'd have to have one of the other sides of each triangle marked to meet the criteria for hypotenuse leg congruence.